don't be scared when you see a solving for reactant in solution problem. You already know how to convert between moles of one reactant or product and moles of another reactant or product. You already know how to convert between moles of something and its mass in grams using molar mass as a conversion factor. The only thing we're adding now is that if one or more of the reactants or products is in an aqueous solution, that you may need to convert between the number of moles of that reactant or product and its concentration in moles per litre. So that would then require the volume or whatever. So in this case, we've been given a balanced chemical equation and we are asked to relate the amount of hydrochloric acid and sodium hydrogen carbonate. So only look at the things you're interested in, right? So hydrochloric acid and sodium hydrogen carbonate, we are relating amount of one reactant to amount of the other reactant, okay? So what we need to do then is in this 250 milliliters of a 0.032 molarity HCl solution, work out how many moles of HCl we have, and then we can convert moles of hydrochloric acid to moles of sodium hydrogen carbonate, and then it's downhill skiing because we can convert moles of sodium hydrogen carbonate to mass in grams using the molar mass. So let's just quickly get the molar mass of sodium hydrogen carbonate because we know we're going to need it. So 22.99 plus 1.008 for the hydrogen plus 12.011 for the carbon plus 3 oxygens, 15.999 gives me 22.99 plus 3 times 15.99 is about 83.918 grams per mole. Okay, so let's reiterate that plan, okay, that we're going to go from the concentration of HCl to the number of moles of HCl, and then from the number of moles of HCl to the number of moles of sodium hydrogen carbonate, and then finally from the moles of sodium hydrogen carbonate to the mass in grams of sodium hydrogen carbonate. Okay, that is our plan. So to get from our concentration to our number of moles, we're going to use our volume in milliliters. So we need to get milliliters into liters as well to make it cancel out, right? Whew, okay. Then to get between our moles of HCl and moles of sodium hydrogen carbonate, we need a mole ratio, which is going to come from the balanced chemical equation. I know it's 1:1. We're going to do it anyway because it's so important to see how those units cancel, and not every equation is going to be as simple as this, okay? And then we're going to use that 1 mole of sodium hydrogen carbonate has a mass of exactly 83.918 grams. Okay, so the concentration of hydrochloric acid, sometimes people get a bit, remember that molarity symbol stands for moles per litre. So I can just write 0.032 moles for every 1 litre of our solution. Okay, so therefore if I times by our volume, which was 250 milliliters, I've got to convert that into liters, so bear with me a second. 1 milliliter is 10 to the minus 3 liters, right? So liters cancel, milliliters cancels. I got my moles of HCl, so I'm going to be pedantic and write moles of HCl here, just because I know we're going to convert it into moles of sodium hydrogen carbonate. So my moles of HCl must go on the bottom to cancel. Okay, remember it may not always be a 1:1 ratio. My moles of sodium hydrogen carbonate go on the top. Okay, and then finally I want to convert moles of sodium hydrogen carbonate to mass in grams, so I use the molar mass of the sodium hydrogen carbonate, which we just calculated to be 83.918 grams. So what do we got here? Make sure everything is cancelling. Oh, whoops, that milliliter got a bit lost there. So liters cancels, milliliters cancels, moles of HCl cancels, moles of sodium hydrogen carbonate cancel. What do we have? 0.032 times 250 times 10 to the power of minus 3 times 83.918 gives me 0.6713 blah 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 grams, and we're asked for 2 significant digits. So boom, there we have it. All right. Let's have a look at another one, shall we? Are they all 1:1 stoichiometries? I hope not. That would be a little bit boring. Ah, hooray! Okay. So this one, we are asked to work out the concentration of tin 2 chloride. So we are relating our mass of silver chloride, which we've been given, which is this guy, to our concentration of tin 2 chloride. Okay, so we do not have a one-to-one stoichiometry here. So I'm going to want to convert mass in milligrams of the silver chloride to the mass in grams of the silver chloride. Once I got the mass in grams, I can get the moles of silver chloride, and then I can convert the moles of silver chloride to the moles of tin 2 chloride. And if I have the moles of tin 2 chloride and I have the volume of the solution, which is 250 milliliters, I can get to the concentration of tin 2 chloride. Notice there was information that I did not use. What didn't I use? I didn't use the concentration of silver nitrate, because technically that is just being added until the silver chloride precipitates. So the silver nitrate is going to be in excess. So that's not really very helpful to me, okay? Because I need to know how much silver nitrate has been added, not just the concentration. So a mass in milligrams, so a mass in grams, I'm going to use the fact that 1 milligram is 10 to the minus 3 grams. Mass in grams to the moles of silver chloride, I'm going to use the molar mass of silver chloride, which silver is 107 point, I can't read this. Come on, 107 point something. Get off there, get off there. 107.868, and chloride is 35.453. So the molar mass of silver chloride is 143.321. I'm just going to put that in there, because I think you're pretty good at molar masses and stuff, so let's not waste too much time on writing out the calculations for that. All right, mole ratio between silver chloride and tin 2 chloride. For every 2 moles of silver chloride that are produced is coming from 1 mole of tin 2 chloride. Now, we're asked for the concentration of tin 2 chloride. Okay, I was just checking we weren't asked for the concentration of chloride ions or something. And then to get to the moles of tin 2 chloride, from the moles to the concentration, we're just going to use the volume, which is 250 milliliters, and we're going to have to convert that into liters. Okay, so 10 to the minus 3 liters for every 1 milliliter. Okay, so that is everything that we are going to need. So let's do it. Mass in milligrams was 5.6 milligrams. Convert to grams. 1 milligram is 10 to the minus 3 grams. All right. Then we're going to convert mass in grams to moles using the molar mass of silver chloride, 143.321 grams. Comma, how very European of me. 1 mole of silver chloride. All right, this is the big one. Mole ratios matter, okay? So for every 1 mole of silver chloride that is formed, 2 moles of silver chloride that is formed. Did I mistype this up here? Oh my god, what? I'm sure I didn't say it wrong, did I? No! This is the fun thing about doing this live. Right, 2 moles of silver chloride. Look, it's right here. Give 1 mole of tin 2 chloride. I'm sure I said that correctly. I think I just hit the wrong button. So, 1 mole of tin 2 chloride. Okay, so my moles of silver chloride will cancel out, and then lastly, I'm going to need to convert moles to concentration. So divided by the 250 milliliters, and then 1 milliliter is 10 to the minus 3 liters. Okay, so let's just double check that all our units will cancel out appropriately. So milligrams cancel, grams cancel, moles of silver chloride cancel, okay, and then milliliters cancel, and I end up with moles of tin 2 chloride per liter, which is molarity. That's what we're asked for. Okay, 5.6 times 10 to the power of minus 3 divided by 143.321 divided by 2 divided by 250 divided by 10 to the power of minus 3 gives me a very small number. And I am curious if you're actually asked to give this in terms of like millimolarity or something, because I don't have the ALEKS answer box, right? So it's 7.8 times 10 to the power of minus 1, 2, 3, 4, 5 moles per liter, okay, on molarity. So if ALEKS had asked to give it in millimoles per liter, I'm not sure if it does or not because I can't see. So then we'd have to use the fact that 1 millimole is 10 to the minus 3 moles. So just in case, this is how you do it, okay? So I don't know. You have to see what the box asks you for. So then the moles would cancel out, and that would give me millimoles per liter. So divided by 10 to the power of minus 3. I don't know, in which case it'd be 0.078 millimoles per liter. You might have even been asked to give it in micromoles per liter, maybe, in which case instead of 10 to the minus 3, it would have been 10 to the minus 6, and that would give you like 78 micromoles per liter. So, I'm not sure exactly what it asks for. Okay. All right. So plenty of practice with that. Always practice with dimensional analysis and SI unit prefixes because we love it, right?